is the complex. What is the complex made up of? Two groups of cells, right? One's called the macula densa, and one's called the juxtaglomerular cells. Pay attention to the diagram and realize that the juxtaglomerulars are the red ones. They're specialized smooth muscle cells. Now, if we go back to this for a second, on average, what is the basic type of epithelia that forms the proximal and distal convoluted tubule?
Simple cuboidal.
Simple cuboidal, right? All right. So here's a cross section of your distal convoluted tubule, and there's your simple cuboidal epithelia. But there's something else different. Look at these guys right there. What would you call that epithelia? Simple columnar. It is only those cells that have that name. These are specialized epithelial cells that are against or adjacent to the efferent and afferent, and they're only found right there. They're not found anywhere else. So if I go back and do my hand little finger idea, right, where this is the afferent, that's the efferent, this is glomerulus, and my wrist is the distal convoluted tubule, it's between my little finger and thumb only that you have the macula densa, and only the part of my wrist up against my hand. It is just these cells right there. Further down and further up, you're back to simple cuboidals. So those are the macula densas. These are the juxtaglomerular cells, specialized smooth muscle cells that together form a complex called the JGC, or some books call it the JGA. Right, for the juxtaglomerular apparatus. This will play a role in controlling your GFR, your glomerular filtration rate that we talked about a bit tonight in lecture. When I look at my glomerulus, I see these little cells that seem to be attacking my capillary and wrapping themselves around it, kind of like astrocytes did for the brain. They create little arm extensions and little foot extensions. So if we go to the next image to kind of magnify that idea, here's an example of what is your three different kinds of capillaries. And this would be then the fenestrated kind, not the continuous or the sinusoid. But I can see the flow of blood or of plasma through my fenestrated capillary. It's going to come out through the large pores of my capillary wall. But then this podocyte, like an octopus, has wrapped itself around it and even taken its arms and these little parts called the pedicles, and it's covering my capillary. But there's a space between the little finger-like pedicles, and that little space is called the filtration slits. That is the space that the filtrate literally gets pushed through. And the podocyte can change the width of that slit. I can make it bigger, or I can make it more narrow. When it's made bigger, more stuff moves through. When it's more narrow, less stuff can move through. Don't worry about what the actual filtration membrane is. But the podocyte is a cell that covers the fenestrated capillary, wrapping itself around it using what are called pedicles. And then the space between the pedicles are the filtration slits. And that's where my filtrate is literally coming out of my fenestrated capillary. This, I'm hoping, looks familiar, because you should have seen this in 241. You had two examples of simple squamous, either lung tissue or a cross-section of a kidney. This actually is a glomerulus. That's the capillary, and those are the podocytes on top of the capillary. There's the fluid-filled space, and there's the wall of your glomerulus itself. That is all simple squamous epithelium, all along through here. This is an electron microscopy image with some bacteria, but you can actually see the pedicles and then the little teeny filtration slits in the arms of the various podocytes that are in there. And that's where we're going to stop. All right, so we'll do the rest on Wednesday.
What is the function of the photocytes? Did you say that?
It helps to regulate filtration
Okay.
rates.
Oh, yeah.
Because they're going to position their pedicles by making that slit larger or more narrow.
Okay.
All right, so with whatever influential vapors you have left, right, definitely at least photograph all the different types of kidney models and plaques. Don't forget the torso models over there. So at least you can begin working on this tomorrow when you're a little more fresh. But don't forget, I'm going to give you a fair amount on Wednesday because I can't torch you next Monday. It's a holiday. There's no